When we have an infinite series, we're adding an infinite number of terms. Now, usually that'll explode to infinity because if we're adding an infinite number of things, we're going to get an infinite sum. But for some series, the infinite sum can be calculated. So in the case of an infinite geometric series, where we have something going down, it's possible that this could converge or have a finite sum. So if I start with 20 and I add 10 plus 5 plus 2.5 and I just keep on going, and this is getting half each time, the Sn formula looks like this. So Sn is equal to 20, and it's going to be 1/2 to the power n. Make that a square bracket here. 1/2 to the power n minus 1, all divided by 1/2 minus 1. And I can simplify that. Okay, so in this essentially is going to be, I can simplify that to, this is divide by negative 1/2, so it becomes negative 40 1/2 to the power n minus 1. And I'll get rid of that negative 40 by just switching those around. So I end up with 40 bracket 1 minus 1/2 to the n. Okay, so I'm going to use that formula to calculate S10 and S20. So S10 is equal to 40 times 1 minus 1 divided by 2 to the power 10. And I end up with 39.96. Calculating S20, I just do the same thing, except I use exponent of 20, power 20. I get 39.99996 ... That's pretty close to 40. And if I just keep going, if I just keep on adding terms, I know that each term is going to be smaller and smaller, smaller. So I'm going to be adding smaller and smaller amounts. So I wonder what the total sum is going to be. It does not look like this sum was going to break 40. In fact, if I try the same formula and just plug in a really big big N, so I'm going to just put in 100. When I plug in S100, my calculator gives me 40 exactly. Now, it's not really 40 exactly, but my calculator cannot calculate all the decimals for this, so it just rounds it to 40. So there seems to be a limit. So I'm going to start introducing some terminology here. So one term is convergence or convergent. What's happening here is that as we add the terms of this series, it's converging to some sum. Okay, in this case, the sum is 40. Okay, it's converging to a sum of 40. So this idea of this converging to us, or having a ceiling to the sum, is called a convergent series. If the sum goes up to infinity, and usually when we add things, infinite number of things is going to just sum to infinity. This is what we call a divergent series. Okay, it never gets closer to limited value. As n gets really, really big, it's just going to go to an infinite sum. And this is called a divergent series. Now, some series, such as this one, not all geometric series, but this series, because it's getting smaller, it has a chance to go have a finite sum because we're adding a smaller and smaller amount, so it may converge to some finite sum. And in this case, it does. So there appears to be a limit as n gets really big because Tn becomes really, really small. Now, I'm going to put a caveat here. Although it may get really, really small, sometimes it's got to get small fast enough because we are adding an infinite number of terms. So if it doesn't get small enough, each term doesn't get small enough quick enough, we may end up with an infinite sum anyways, although the terms might still be getting smaller. So this case here in an infinite geometric series, it appears that infinite geometric series are convergent. They have a finite sum.